tardes. Gracias para su invitación a hablar con ustedes esta tarde. El mismo que otras personas en la conferencia, quisiera que hablar con ustedes en español, pero el mismo no tengo mucho español. Estoy muy contento. Hay traductores expertos esta semana. And with that, I will let them take over, and we will make this a lot more efficient by having them translate. And they have been excellent, so I really appreciate that. When I've had to listen on the headphones, it's been just wonderful. And I'd also like to thank the ministries and the agencies for inviting us, but also especially Anna Cristina and her colleagues for making this such a wonderful workshop and for doing all of the work necessary to make it so. And she really has done a wonderful job. So I appreciate her and all of the colleagues. My two topics I have. This first today is on ecosystem impacts and mitigating measures. And I am interrupting the coffee break. So I will not be the least bit offended if you want to go get coffee or something to eat while I'm talking, because I realize that it can be a long afternoon. Or if we want to split it halfway and talk for a while and then go get coffee. So anyway, what I'd like to do is, okay. So what I'd like to do, this is a brief outline of what I'm going to do in the next hour. I want to talk a little bit about my relevant experience, partly to explain why the heck I'm here, but also to give you a little bit of a sense of other resources that are available to you after this conference is over. And so I'll talk about those a little bit, and then I'll get into the substance of my words this afternoon, evaluating ecosystem impacts, and doing that from a couple of different perspectives, and I'll go into detail as I go along, and also mitigating those impacts. So the Natural Resources Law Center at the University of Colorado School of Law has a couple of different hydrocarbon-related projects. The first and my main project is called the Intermountain Oil and Gas Best Management Practices Project. So it is not a project that is a proponent of oil and gas development or an opponent of oil and gas development, but simply takes the position, if it's going to be developed, these are some best practices that should be used in order to make it as environmentally conscious as possible. It's a very small geographic area. We are just working in 5 states of the Intermountain West, and we concentrate on those areas, although many of the best practices are more applicable across the country and perhaps across the world as well. The project is part of a larger project called the Environmentally Friendly Drilling Project. We started ours with private funding and then have been getting some funding from the U.S. government, the Department of Energy, which also has corporate cost share money associated with it. Some of the projects we've done have been related to my Intermountain Best Management Practices project, but also the Ukraine project that Anna Cristina mentioned is part of that EFD project, where we helped the U.S. Agency for International Development do an environmental impact assessment on their assistance to the government of Ukraine, and then also an analysis of the laws of Ukraine in regard to shale gas development and whether or not those laws would be adequate for a sustainable development of shale gas. A second project that we're just starting with the Environmentally Friendly Drilling Group is called the Technology Integration Project, and this one is more intended to take technologies that have been developed in the lab or in concept and actually get them into the field and see if they work, see if they actually are more environmentally friendly. And there are a variety of projects that are going to be done. And this is also funded by the U.S. government, Department of Energy, through something called the Research Partnership to Secure Energy for America. Our role in this is mostly outreach, so it is getting information on technologies available to people, similar to the Best Management Practices project. I think some of the technologies that are going to be tested in this project might be also valuable to Columbia and other places as well. So, and there will be a website under the efdsystems.org. A couple of types of outreach, a couple of types of information that I think might be valuable to you. This is one example where it's generic information about unconventional gas development. The panel on the left is basically a tour of exploring a virtual drill rig. So how does it work? What does it do? And then you can investigate what some of the best practices are that use the particular technologies. On the right is a book put together, just very small part by the EFD group, but on hydraulic fracturing and just general information on hydraulic fracturing. So that's the kind of information that might be valuable to you in general. Also part of the project is more site-specific information. For example, this is an example of a website for the Fayetteville Shale. So it has any information you'd want on the Fayetteville Shale, what's being done there, how it's being done, who's operating, and best practices. And so this is something that might be valuable to Columbia to have. Obviously, a computer-based or internet-based information source is only available to people with computers and all that, but you know that's changing rapidly, and that's the way of getting information these days. So hopefully it will be it could be useful for Columbian development as well. And the last project I'll just touch on is it's called the Roots to Sustainability. This is a new project that we have at the University of Colorado with many different partners at other universities, but it's funded by the National Science Foundation specifically to look at air and water issues related to unconventional gas development. The point of mentioning these studies and also referring you back to some of the studies that people have talked about over this last day and a half is that there's a lot of good information out there. It's available on unconventional gas development. There are many recent technology improvements that have been made, for example, relating to hydraulic fracturing and water management, water use. There is more research needed, and there's more research being done to improve both the practices and also the mitigation measures that might be implemented to protect the environment. And Columbia, just as the United States, can benefit from all of these in current development and in future, and can benefit from the future investigations as well. And to do that, you have to know what's out there. You have to know what's being done. And I think this conference is a wonderful first step in knowing what's out there and what's available to people. But in addition to that, not only knowing it, you have to either require or strongly recommend that those practices be instituted in your particular development. But unless you know that they exist, it's hard to either request them or demand them. And I think the other thing is you have to know that there are choices. So in a lot of cases, it's not that things can't be done to better protect the environment, but it's an economic choice, and it's a political choice that those things be done. And you know, there are lots of elements to those choices, and I think John just talked about some of those as well. But they are choices that have to be made, and it is best to do it on basically a full deck of knowledge. So on to Columbia. I don't know much about Columbia. I wish I knew more. I know it is one of the most diverse countries in the world. This slide says it's in the top 10. I've also seen it as the top 2 or 3, and I'm not going to decide on that one myself. But I know it's very diverse. I know it has a lot of forests remaining in the area. It has many natural national parks and other protected areas, maybe as much as 10% of the national territory. But I also know that it has lost biodiversity in the last number of decades, and that is a problem, not necessarily all or specifically from oil and gas development, but from many uses, and so that can be a problem. The top map, I don't think you can probably see very well, but the green areas are natural areas, and then the bottom map is as much as I know about where the unconventional gas development possibilities are. So there's some overlap, there's some not. But I'll talk a little bit later about, you know, you have to, one of the political decisions you have to make is what areas should be excluded from oil and gas development, even if they are good areas for production. Just in a bit of contrast, United States, we don't have tropical forests. We have some beautiful forests. You've seen some pictures of unconventional gas development areas with the rolling hills and some steep topography in the eastern United States, in Pennsylvania and Ohio and New York. When you get out west, you have more deserts, you have more ranch lands. Some people who would look at them and say, you can do whatever you want with them. I think there was a picture, I can't remember whose it was, earlier yesterday, where there were, it looked like a moonscape with oil and gas wells in Wyoming, just gas well after gas well after gas well, and then a better picture where the gas wells were consolidated and there was less disturbance of the environment. So we have all types of environments in the United States that we're trying to protect. The other kind of development we have is development right in the cities, right in the cities. The picture of Penn State, I think, a well being developed on the campus, but we have them in our suburbs and in our urban areas of Colorado. We also have them, some would say, threatening our national parks or our special protected areas. Our laws generally do not permit oil and gas development in our parks, but they do permit it in some of our national monuments and other protected areas, and that's a very controversial issue. Hopefully I'll get into a little bit more of that as well this afternoon. So basically, I guess what I'm saying is, I don't know much about Colombia. I'm going to use some examples from the US and also from Ukraine, since I worked a little bit with the folks there, and hopefully you can take what is applicable to Colombia and leave the rest. First, a little bit of distinction between conventional and unconventional gas, and this has been done quite a bit in the last few hours, but also then I'll get into identifying impacts, ecosystem impacts that can be looked at in a number of different ways. And I think it's important to look at some different ways of evaluating impacts. The ways I have indicated here, direct, indirect, and cumulative impacts, evaluation by development phase of the drilling and production, and then also just looking at the environmental footprint of an operation according to the particular resources that you might want to protect. So just some of the major differences, and I have really enjoyed sitting in on the presentations. I thought I knew a lot about unconventional gas development, but I have learned a lot as well. So I can imagine that everyone is enjoying this. And we all have our different topics that we prefer, but just very good information. And I think one takeaway I've come up with is that it is a huge industrial development. I mean, you can't think of this as small, easy to hide in the jungle, easy to hide, you know, on the banks of the river. This is a huge industrial development, and it has to be planned well, and it has to be recognized as what it is and dealt with. One of the differences is the question of the horizontal drilling, which in many cases allows drilling from one location to reach many different locations, and that has some flexibility for placement of wells. So I've always thought about it as the opportunity to say, okay, I wanted to develop the oil and gas or the gas underneath this table, but I don't have to drill at that table if I want to protect some resource there. I can drill from farther away. When Jose was speaking to us yesterday about drilling, I got the impression that it might not be quite that flexible. if you're wanting to do your hydraulic fracturing in a particular orientation. So I think that has to be just recognized, and I don't know enough about that to be the one to say, you know, what decisions you can and can't make. And certainly the hydraulic fracturing. I think someone this morning, it's all running together, said that there were 400 people and doing 150 jobs during a hydraulic fracturing operation, taking up about 2 hectares. I think it was David. And to think about that, and you're drilling 30 wells, 40 wells. Some of the developments in the Piceance Basin of Colorado, I think the maximum so far is like 47 wells from one well pad. But you're doing those 400 people doing 150 jobs 40 separate times in that location. So no matter how short the time period is of development, it's a large-scale development, and you have to deal with it. So differences between the conventional and unconventional gas hydraulic fracturing is not new, as we've heard, but the timing of it, the number of fracs per well, the amount of water used, the amount of sand, the train loads, the train cars full of sand needed for fracking one well, to get that logistically into a place in a rural area of Colombia would be quite a feat. And then, of course, production and disposal of water. And Anna Cristina warned me not to talk much about water, and I know why. We've heard wonderful, just fantastic information about water today, and I'm going to leave it at that. So identifying impacts. Just what I want to get to here is not any specific impacts, but the idea that it's important to look at different types of impacts. So direct or primary impacts. Indirect or secondary impacts, and then also cumulative impacts. And when I say primary or secondary, I don't mean important or less important. What I mean is, and you can kind of see from, try to get the pointer to work, from the first column, direct impacts are the result of the project activity. They would be geographically close to where the project is being placed. They are more likely to be immediate effects of the project during the project life cycle. And they are very likely to be more easily estimated or predicted in the environmental impact assessment. And I'll talk about that a little bit tomorrow. And they are also more likely to be easily minimized or avoided through actual development of the project. And in contrast, the indirect or secondary impacts, they're triggered by the operations of the project, but they're not necessarily integral part of the project. And they may reach outside the zone of the project development. They might begin before or end after the life cycle of the project. And they also may not be recognized until farther into the project. And they are more often the results of government action or the actions of in-migrants to the area based on access or opportunities actually created by the project. An example of that, of the difference between primary and secondary impacts, would be that a primary impact would be the clearing of an area for a well pad or a fracking operation or something like that, where you have to remove the canopy of the forest. The infrastructure is put there. That causes a direct loss of habitat for animals or plants. It also might lead to soil erosion if it's not done properly, and that soil erosion might contaminate a waterway. Those are all direct impacts, and you can prevent those erosion. You can prevent that erosion. You can prevent that contamination of the waterway. You can limit the amount of disturbance to the forest. But then you might have a secondary impact of the clearing leading to weeds or non-native plants brought into an area, or other species brought into the area that are sort of hazardous to the health of the native species. And that can be from transportation of equipment and supplies, or it can be, again, from individuals who come to the area that were not originally part of the project at all. And then the third column, the cumulative impacts. Cumulative impacts are something that we think And in the United States, it's required to consider when you're doing an environmental impact assessment, but they're the result of a wide range of activities, both existing activities, existing disturbances to the environment, the proposed action of the gas development, and then also future projects that may not be even anticipated. And part of the effort is to anticipate those projects. It again can reach outside the project area. They can be immediate and future impacts, and they're also often ignored in the environmental impact assessment, even if they're required. And there's seems like a lot of litigation in the United States about whether or not cumulative impacts were actually considered, and it is often thrown back to the agency to redo. And the reason, I think, is that it's just that the project itself is the most important thing that you're considering, and you're wanting to get that right. But unless you also consider the cumulative impacts, you can get it really wrong by ignoring the cumulative impacts. So long-term planning is a really important way of dealing with the cumulative impacts. A second way of just an approach to evaluating impacts from a development is looking at the life cycle. And this is just a real schematic of the life cycle of natural gas. And this is the only part that we're really talking about today. Production and even a tiny bit of processing. So all of the upstream development of oil and gas. And the transmission and storage, distribution and all that is another topic. But that might be important to consider in the cumulative impacts as well. So one of the resources that I use, since I really don't know much about tropical environments and biodiversity and ecosystems outside the U.S., is something called the Energy and Biodiversity Initiative, and the website is down at the bottom. Oh, and I will mention, despite Anna Christina's best efforts, I could not get her these presentations in a timely manner to get on your flash drives. So I'm sure that they're going to be distributed, and we'll actually put it on our website as well, because I hope that some of the resources that I indicate, references I indicate on the slides will be of use to you. And I'll explain this one especially a little bit in a bit. So some of the life cycle processes that Energy and Biodiversity Initiative deals with are seismic activity, and then exploration and appraisal drilling, field development, production, transmission within the field. I'm not talking about long-range transmission of gas or anything else, and then decommissioning. And just some other terminology that's used. For example, for decommissioning, some folks talk about reclamation or restoration, and linear facilities. And each of them has, in general, I mean not always, but in general, you might be talking about small scale or short-term impacts from seismic activity, but large-scale long-term impacts from actual production. And then back again when you're restoring the area after for decommissioning, you might be back to small scale and short-term. And it's just a way of thinking about thinking about impacts and what you're going to have to deal with and how long you're going to have to deal with those impacts. I'm going to make a case. We heard a case made for baseline studies frequently this morning, and I'm going to, I think, repeatedly make a case for reclamation and restoration, and thinking about reclamation and restoration way back at the beginning when you're beginning your seismic activity, or especially when you're starting your field development. You have to think about how you're going to reclaim something before you disturb it, or you're never going to get the success that you really want. We have one case study on our website, on our BMP website, where Encana, who's a mid-sized developer, I guess you'd say, in Colorado, has what they call a lifespan planning approach to restoration. So they don't move a bit of dirt on the ground until they have planned their restoration for a particular well site. And they've been doing this for, maybe 10 years. And they really feel like it saves them money in the long term because they have a better sense of what they need for reclamation, and it gives them a better product because everything is planned ahead of time. Okay, and the last kind of way of looking at impacts to the ecosystem, the evaluation of impacts, the evaluation of impacts itself is kind of in the blue, looking at the flora, the fauna, the biodiversity of an area, and things that I'm not going to talk about, which are air, surface water, and groundwater. Those are important, but you really have to start, as we've heard several times today, with establishing the baseline, because you have to know what you have in order to evaluate what kind of impacts you have to it. So what is going to be disturbed? What are the resource types that are out there? That baseline can, in some way, a baseline in some way can help you identify whether or not there should be some exclusion areas. Are there areas in Columbia where you shouldn't develop, even if there are resources? And what are the reasons for that? Without the baseline, without knowing what you have out there, you can't make those decisions. And once you start developing, it's too late to make those decisions. The other aspect of this, other than identifying the actual impacts, is to look at the larger implications of impacting the flora, the fauna. So what are the ecosystem services that you're going to lose if you destroy something in terms of water or air, wetlands or riparian areas? So those are sort of a larger perspective, and I'll talk a little bit more about that tomorrow in the environmental impact assessment area. And then the last is, okay, you can identify all sorts of potential impacts, but what do you do to minimize those impacts? What do you do to mitigate that? What do you do to reduce them to a reasonable degree? So some basically impacts to biodiversity in a general sense. The first is actually the positive, and John mentioned that and talked a bit about that just in the last presentation. The idea that you're actually improving or protecting biodiversity by decreasing the potential for macro environmental change or climate change by using gas. So there are pluses to biodiversity from gas development. The other ones, I'm afraid, are all threats to biodiversity. And I think the main one is just the surface impacts of development, the conversion, loss, degradation, and fragmentation of natural habitats. Again, you can reduce those to a certain extent, but that's the main thing that happens in an oil and gas development. This could be including all the vegetation that's removed for the footprint of the drilling rig, the pipeline, the transmission facilities, the waste disposal areas, the spill containment areas. We saw pictures of how some of the ill effects of a spill might be mitigated by having a containment facility, but all of those areas take up space, and one of the features of unconventional gas is this consolidation of facilities in one place that can be very good in terms of minimizing the spread out impact and the fragmentation of habitat, but it also can have its downsides as well. And all of them have to be weighed. The second is over-harvesting or over-exploitation of a particular species. And in terms of oil and gas development, this would be more of a secondary impact. So are there people going to be coming to the area to support this 400 person project that would be using the biological resources of the area and exploiting species, and either legally or illegally. The third I've mentioned already, non-native species and weed introduction can be a major problem. And this is not simply a problem that I've heard is expected in tropical areas, but Canada has had particular problems with that, and pipelines, and even revegetating the pipeline using native species, but having invasions of weeds and fungus that get into the soil. So that can be a problem that you have to deal with also. And then the last is pollution and contamination. So these are when things go wrong. How are you polluting? When you're emitting methane from your pipelines or your facilities, it doesn't have to be done. You're not intentionally doing it, but it just it occurs and it pollutes the air or the land and the water. Some of the, when we worked in Ukraine, we were asked to look at, again, their regulations, and or really not their regulations. We didn't get down to that particular level. We more looked at a higher level, the laws of the country, and to make recommendations for what they needed to do. And some of these may be of use to you, so I'll go through a few of them quickly. And the first comes up again, baseline data collection. A complete survey and mapping of vegetation communities to provide a baseline for evaluating the impacts. This is important in all countries, and it's important in the U.S., and it's done to some extent. And we have surveys of endangered plants and endangered animals and natural areas, and we try to protect those areas. But unless you know what's there, you're not going to protect them. Improving monitor. Oops, I just flipped back a couple. Oh, improving monitoring and enforcement capacity, and I think John mentioned this as well. In Ukraine, it was particularly a problem in the question of protecting their biodiversity, protecting their natural areas. They did not have the staff, they did not have the resources to do it. They had the laws, but they just didn't have the capacity within the country to do it. The other thing that they didn't have and recognized as a problem was maybe the culture to fairly enforce the laws. So it was very selective, and it was almost based on a quota system. You had to come up with a certain number of violations, and even if they were minor, you had to come up with them. And it was just not a good system for maintaining good relationships with or even good work habits with the industries that they were regulating. John talked about the increase in personnel in the Pennsylvania staff for enforcement and monitoring in Pennsylvania. Colorado has 17. I mean, John had 88 and raised it to 200 and something. We have 17 inspectors. Now, we don't have quite as many wells as Pennsylvania, but that's an incredible number of wells. It is an incredible number of wells per inspector. So you can't expect careful monitoring. So this idea of having a culture of safety and a culture of good practices is really important, but a lot of people are pushing in Colorado to get more inspectors. Let's see. Just highlighting a couple more. Let's see. Reducing impacts. The question of somehow developing a system for payments for ecosystem services and maintaining ecosystem services. That's more of not a mitigation measure, but a compensation measure if mitigation is not, it cannot be complete within the structure of the project. And again, I'll talk a little bit about that tomorrow. I think I'm getting close to needing a coffee break. Okay, down here, restoration and monitoring. One of the things that Ukraine did not have is they had an insurance system, but they didn't really have a bonding system. So for protection, I mean, what you want to have is good development where nothing goes wrong. If you have good development where something goes wrong and you can repair it, that's great. If you have something that goes wrong and you can't repair it and you have to compensate for the environmental impacts, you need a good system of either insurance or bonding for that. And so that was one of the things that Ukraine was going to work on. And I guess part of that also, and this fits in with the biodiversity as well, but the idea of including off-site mitigation projects for protecting high biodiversity areas if you can't completely protect the reasonable areas of biodiversity in your project areas. This, I know you can't read, but again, this is a resource that I hope you will come back to, and it is again from the Energy and Biodiversity Initiative. This is a very small part of a very long list of potential impacts or potential results of oil and gas development, and then good practices to mitigate them, to compensate, or not compensate for them, but to prevent problems. And they take it from seismic through all of the stages of the oil and gas development that I had on that previous slide, through seismic, through exploration drilling, through production, creating the production areas, and et cetera, et cetera, et cetera. And they have a lot of specific recommendations for good practices, and they are specifically intended for more tropical areas, certainly not for the U.S. So I recommend it to you as kind of a checklist for Columbia to look at and say, okay, do these apply to us? Are we going to have helicopter pads? Are we going to have man camps for development? What do we want to do in terms of staying close to a river in order to minimize impacts? Okay, so now after you identify what a potential impact is, then the next step is to really look at what the best practices are for mitigating that. And we have a really, people differ on this, but we take a very broad view of what a best management practice is, and we include laws and regulations, and that might be international, country, state laws, local government laws in the United States, because that matters, a question of corporate social responsibility, and also things that are kind of created in terms of the community and industry. So I guess the question is, and maybe this has already been answered to people's satisfaction in this last day and a half, but what are basically why do you want to be incorporating best management practices in a development? And the first is to have a sustainable development, to protect the social and economic and also environmental values that you have in your country and that you're trying to maintain. Economic value is of course important to in the natural gas development, but there are other values as well. In many cases, they can be cost effective. They can be cheaper to build than than the non-best management way. And an example of this, I guess an example of this is in Canada and their reclamation program. They've found that if they spend more money in performing the reclamation, they will save money in the long run because they will be required to do it right. They will be required to have success. And so if they do it right the first time, they save all of the remobilization costs, the cost of additional materials, et cetera, et cetera, et cetera, the heartbreak of having to be told to do it over again. And they've just found that it's just more cost effective. I'll give an example later in the air quality arena where companies have gotten together and talked about what are the different processes that save gas that can be then captured and sold, and how the best practices they use to eliminate stray emissions can be actually cost effective, or at least having a reasonable payback period. And of course, if you're going to evaluate the economic costs and benefits of either a project or using best management practices, you have, I really flipped along. You have to consider the externalities. Someone is going to have to pay for those, so if you incorporate them in the development, it makes a lot more sense for the entire project. And then the last reason for incorporating best management practices in development is certainly because you get community support. And without community support, you're going to lose time, you're going to lose money, and you're not going to have as good a result. If I have time a bit later, or maybe in questions, I can talk about some of the community industry cooperative efforts that have occurred in the United States, particularly in Colorado, that have come up with a lot better results in terms of development, a lot less contentious development than is otherwise more common. This is just another sort of take it or leave it from the Colombian perspective, but the entry points at which the United States and Ukraine can put best management practices into a development. In terms of the United States, resource planning is the first way, and we have federal, state, and local laws related to oil and gas development and lands. So the peculiarity of the United States versus both Colombia and Ukraine is that our oil and gas is not all owned by the country, by the federal agency or the federal government. It can be owned by individuals. It can also be owned by state governments or local governments and the federal government. So you might have resource planning, land surface planning that by any of those agencies, whether or not they own the oil and gas development or not, or the oil and gas resource or not. Another entry point is in the leasing, and that gets to who owns the gas. So the federal government, for example, has both individual leases and then also master leasing plans. So if there's going to be a large development, they might lease it as in a large section, and this is a lot in the western United States where we have a lot of federal lands, and then incorporate the best management practices at that point. A second point, even if it's not incorporated in the lease, might be in the permit stage. And again, you can have individual permits for individual wells, or you can have a master development plan where you look at the development on a larger scale and incorporate your best practices at that level. In contrast, Ukraine pretty much just didn't have resource planning in general. They had it for their protected areas, was about it. You could incorporate best practices in a license or a production sharing agreement, which is the method they were using or trying to convert to, especially for essentially leasing their oil and gas or individual permits. A couple of other ways of introducing best management practices is operator voluntary measures, and this gets into the social responsibility to some extent. Innovation, what you don't want to do, or what we try not to do in the United States, and I think we're accused of a lot, is stifling innovation by having one-size-fits-all rules, and we don't want to do that. We want to give people, the A+ students of the class, the opportunity to innovate, the opportunity to show their corporate responsibility, and that they can do things in a cost-effective way that fits their style of operation. And if they can do it, more power to them. Again, because we have both federal, state, and privately owned energy resources, you might get a surface use agreement that is a private agreement between an operator and an individual citizen of the U.S. And that can include best management practices. A joint lease agreement, that has a couple of different definitions, but in this case what I'm talking about is landowners joining together, and it might be, for example, in a community and saying, this is what we want for our community, this is how we will lease our land if you follow these practices. And then actually Dave Neslin tomorrow may talk about this a little bit, and watershed agreements and negotiated agreements. These are some of the things that have been done in Colorado where industry and the communities have worked together to come up with what they think is a good combination of practices for their communities. This is just a series of panels of different kinds of reports, and these go into a lot more detail in terms of best practices. This, down in this corner, are these energy and biodiversity reports, and this is where that long table of different measures are. This is our website. This is the Marcellus Coalition's suggestions for best practices. I think this is Pennsylvania. I can't even read it from here. This is coal bed methane best practices for Montana. Most of these are recommendations. They're not requirements, but they are just a resource for people to say, okay, what's out there? Who's doing what? What's considered a best practice? So some kind of resources for you to go back to. This one is a report that just came out a couple months ago, and it's on best practices for oil and gas in tropical forests. There was just, I think, a small conference a couple days ago in Lima talking about some specific practices. I think this one is available in Spanish as well, and I have a little bit more information on this. And some of the recommendations for tropical ecosystems, and again, I'll say, I took this from the report. I don't know that much about tropical ecosystems and what's necessary, but some of the recommendations they make are permanent roads and camps, limiting them from beyond the vicinity of a navigable river. And one down here, transport, air and river transport. Do it as much as possible by river, and then limit the size and frequency of that, even so that you're not overloading the system. This is for conventional development, so they're talking about extended reach drills. They're not even getting into the horizontal drilling, but the idea is that you can put the drill pad a far distance from where you're really trying to develop. Keeping a separation between the drilling production platforms, so a minimum separation so that you're not basically fragmenting the entire ecosystem. One recommendation that I'm not sure of is this idea of limiting seismic testing. Well, limiting seismic testing to areas with high demonstrated probability of deposits. I think the idea is to limit the impact, the surface impacts of seismic testing, but I think we heard earlier today and yesterday about the really importance of careful characterization of an area before you really decide what you're going to do. And I don't know if you can do that by, maybe if you're just doing it in a high demonstrated probability area, that's what you want. And then again, emphasizing once more that you have a development plan before you get in there and start developing. Some of the other sort of types of mitigation measures for biological resources would be timing constraints. Not developing in certain time periods if you're trying to protect the mating areas or the in our case it's wintering areas for certain species. That can be really problematic if you've got a large scale development that has that for economic purposes needs to continue development and have one well after another, after another, after another. So if you're considering timing restrictions, you have to figure out whether or not that's going to fit with the development or not. And timing restrictions can also, someone mentioned yesterday, can also be a benefit to people. If you're not permitting certain activities to happen at night, it can protect people as well. And then the other is just exclusion areas if you can't come up with mitigation methods. Frac focus, someone spent a lot of time on, and a good resource. Natural gas star is the other resource I mentioned where it's industry talking about the best practices or technologies they've developed to minimize impacts on air resources. And most of these are cost effective, and they actually talk about the payback period, the cost of implementing them and the payback period for them. Okay, this is my summary slide. And I think that the idea is, so for planning for ecosystem protection, I think there are a number of things that can be done. And the first one is to convene outside experts to share information, to learn from other people's successes and to learn from other people's mistakes. And you have taken that first step by convening this group. And I know you've done other investigations before bringing us here to talk about it. But I think those are very good first steps. The second is to engage local governments, communities, and indigenous groups. You have to have the buy-in of the people in the area, whether it be from the urban areas or from the communities that are going to be affected by it or benefit from the development. I think there's a principle that says no matter how, I was thinking about this when John was talking about changes in the rules in Pennsylvania. We're doing the same kind of rulemaking in Colorado right now. And no matter how good the regulation ends up and how protective it is, it's not going to be good enough if the people that it affects have not participated in the development of that regulation. You've got to have buy-in and participation, or there's got to be something better. Something's better on the other side. Again, in summary, plan and begin baseline studies guided by your area experts, so guided by the people who know the kind of environments that you have in Columbia. And those have to be started early. I think for Ukraine, they recommended, and this wasn't my recommendation, but the water experts recommended 3 years of water studies before development. If you're going to do animal and plant surveys, you might have to consider the seasons of the year. If you've got ephemeral water systems, you might have to consider the highs and lows, the droughts and the high periods. After all this, know the standards and demand the highest standards from both national and international production companies. The idea is to protect the resources that Columbia has, to develop new resources, to use those resources for the benefit of the community. And you have to know the highest standards and also decide if you can demand them. One thing I didn't put in here, so I'm going to slip this in, and that is monitor. Monitor and be willing to deal with the answer. So if you get an answer that that's something that you've planned and spent a lot of time and money planning is causing damage, you have to have decided ahead of time whether or not you're going to act on that and actually fix the problem, or maybe you're not and you're going to compensate folks for the problems caused. But there's no point in monitoring if you're not going to take the data that you get and actually deal with it. And that ability to deal with those monitoring results, I believe, has to be part of your license agreements or your contractor agreements, or you're going to be stuck not getting the action you want. And then the last, as I say, I know very little about your national laws and policies. I have a little bit on that tomorrow, and I'm just going to kind of guess at some things, but maybe a review of the national laws and regulations to see whether or not you think that they are protective enough, maybe comparing them to some other international laws or other state laws, and see if you can learn something from those as well. And that's it. Again, contact information, the website for our project. We have some of the resources that I've talked about that may be useful to you, and I hope they will be.